So in this video I'm going to run through all of the questions for SC 14.5, which is on molar volume. So we did SC 14 originally back in year 10, we just didn't finish this particular section, and it is a paper 1 topic. These are all the exam questions, by the way, so if you can do all of these comfortably, then you should be well set for your exam. So first question here, you are asked, you're given the volume of propane, all right, so decimeters cubed is a volume, and you're asked for the mass of hydrogen in kilograms. Okay, so I drew myself out a little moles table, including propane and hydrogen, because I'm given a volume. I've got volume, molar volume, moles, and ratio down the side. So my volume is 900, molar volume is always 24, so I just do 900 divided by 24, and I can work out the moles of propane. I can then use the ratio for my balanced equation, which is 1:1, to work out the moles of hydrogen. Now, if I were to fill in the rest of that table, I would be getting the volume of hydrogen produced. You are asked for the mass. But once you know moles of hydrogen, you're going to use your G Mr. Moles triangle. If you know moles and you want to know mass, you're just going to multiply by formula mass. Formula mass of hydrogen is 2, right? There's 2 hydrogen atoms, each with a mass of 1. So it's 37.5 times 2 is 75 grams. When you use G Mr. Moles, your answer will always be in grams. But you're asked for your answer in kilograms. To go from grams to kilograms, you just divide by 1,000. Your final answer is 0.075. Well, the next question is something similar, but this time they give you a starting mass and they ask for your final answer to be a volume. So they've given you 10 grams of ammonium chloride and they're asking you about the volume of ammonia gas that could be formed. So ammonium chloride is here, NH4Cl. Given me 10 grams, I work out the formula mass of ammonium chloride and it's 53.5. Just note, we don't use the big numbers in the equation for formula mass, we only use that for ratio, so don't times this by 2, alright, it should be 53.5. To work out the moles, it's mass divided by formula mass to work out moles, and then I can see that the ratio between my ammonium chloride and my ammonia is 2:2, which simplifies to 1:1, which means this is the number of moles of ammonia gas I've got. Again, if I filled in the rest of this table, I would be getting the mass of ammonia. You're not asked for the mass of ammonia, you're asked for the volume. And once I know moles, I'm going to use volume equals moles times 24. So 24, remember, is just your molar volume, and it's the same for every gas. I times those twos together, and I get my answer in decimeters cubed, 4.49 decimeters cubed. And the next one is, I would say, a little bit trickier. Okay, this is probably the harder question that comes up. So they've asked you to calculate the minimum volume of air. Now notice they've said air, they haven't just said oxygen. In air, you've got nitrogen, oxygen, argon, CO2, and only 20%, or 21% typically, but they're telling you here only 20% of air is actually made up of oxygen. So what you're going to need to do is you're going to need to calculate the volume of oxygen needed to react with NO. And once you know how much oxygen is needed, you're going to have to use this percentage to work out the volume of air that is needed. So we'll start by just working out how much oxygen is needed to react with nitrogen oxide. So they've given me the mass of nitrogen oxide in grams. So I work out the formula mass of nitrogen oxide, so NO is just 14 and 16 is 30, so it's going to be 1000 divided by 30 is 33.3 recurring. If I look at my balanced equation, I've got a 2:1 ratio between NO and oxygen, so I've got that there, 2:1, which means I'm going to divide this by 2 to work out the number of moles of oxygen gas that I need. Once I know the number of moles of oxygen, I can work out the volume of oxygen. So the volume of oxygen is going to be the moles of oxygen times by 24, and I work out that I need 400 decimeters cubed of oxygen in order to completely react with 1000 grams of nitrogen oxide. But check the question. You're not asked how much oxygen do you need, you're asked how much air do you need. And oxygen only makes up 20% of air. In other words, oxygen is only 1/5 of air. Therefore, I'm going to need 5 times this, so 400 times 5, 200 decimeters cubed is the volume of air, because if only 20% of air is oxygen, then using 2000 decimeters cubed of air will give me the 400 decimeters cubed of oxygen that I've just calculated I need. So I'm multiplying my volume of oxygen by 5 to work out how much air I need, knowing that most of air is just nitrogen. Whatever percentage they give you is the percentage there that you are going to use. Okay, they'll always tell you it's 20%, so then you can just multiply by 5 at the end. If they didn't tell you it was 20%, if they told you it was 21% instead, which is more accurate, you're going to do 400 times by 100 divided by 21. Okay, so here I did 100 divided by 20 and got 5, so I just wrote in 5, but here it'd be 100 divided by 21 times by 400. If they randomly told you that in this particular sample of air, oxygen was making up 37%, it would be 100 divided by 37 and then multiplied by the volume of oxygen that you've calculated that you need. And the next question, a little bit more straightforward, it's just a 2-marker. So calculate the volume of 48 grams of oxygen. Okay, if I want to calculate volume, it's going to be molar volume, which is always 24. Again, you're given that in the question, times moles. So I first need to find out moles. Moles of oxygen is going to be 48 divided by the formula mass of oxygen. You need to remember that oxygen is O2. So the formula mass there is 32, not 16. So I've got 1.5 moles of oxygen if I've got 48 grams, and 1.5 moles times it by 24 will take up 36 decimeters cubed. All right, the next one is about glucose becoming carbon dioxide. So they tell you you're starting off with 75 kilos of glucose. You need to put that into grams. So 75 kilos is 75,000 grams. They give you the formula mass of glucose. It tells you it's 180. Yeah, it's there. So 75,000 divided by 180, you can work out the number of moles of glucose that you are starting with. You then need to use your ratio, which is 1:2, to work out how many moles of carbon dioxide you are going to produce. And they don't ask you for the mass of carbon dioxide, so there's no point in filling in this table. They ask you for the volume of carbon dioxide. So once I know moles, it's going to be moles multiplied by 24 equals 20,000 decimeters cubed. And your answer there will be in decimeters cubed because you've times by 24. Sneakily enough, they give you the formula mass of ethanol, even though you're not required to use it. So typically if they give you information, they want you to use it. In this case, in this question, they don't. The next one over here, calculate mass in kilograms of 750 decimeters cubed of sulfur dioxide. So again, they've given you a volume. They want you to convert it to a mass. The only way you can do that is by going through moles. So if you've got 750 decimeters cubed, divide by 24, you'll work out the number of moles you have. Once we know moles, we can easily turn it into mass by doing moles times formula mass. So it's going to be moles times formula mass equals 2,000 grams. You're always going to get your answer in grams using that formula triangle. They ask you for kilograms. 2,000 divided by 1,000 is 2 kg. So your answer there is going to be 2 kg. The next one, it says calculate the volume of oxygen needed to completely react with 750 decimeters cubed. There's a reason this is only worth 1 mark, okay? When you're dealing with volume, you don't need to convert to moles. You can just use the ratio straight away. So they tell you you've got 750 decimeters cubed of sulfur dioxide. You can see you have got a 2:1 ratio between sulfur dioxide and oxygen. I don't need to convert to moles. All I need to do is half the 750 and get 375. 375 decimeters cubed, okay? And the reason I don't need to convert to moles is if I did, I would be dividing this by 24, working out moles, and then timesing this by 24 to get back to volume. Because I'm using 24, regardless of the gas, there's no need to do it. If you've got mass, each formula mass is different depending on the compound involved, so you do need to convert to moles, but with volume the number is always 24, therefore there's no need to do that calculation. Number 8 is incredibly similar. Okay, the maximum volume of propene in decimeters cubed formed by the dehydrogenation of 300 decimeters cubed of propane. You're starting off with 300 decimeters cubed. You've got a 1:1 ratio between propane and propene. Therefore, you're going to get 300 decimeters cubed of propene. Okay, you're also going to get 300 decimeters cubed of hydrogen gas. Now this, I know that might seem like you're kind of going against the law of conservation of mass. You're starting off with a volume of 300 and then you're making 300 propene and 300 hydrogen, but all you're doing is you're just breaking this molecule in two, so you're creating more gas molecules. You've got one gas molecule on the left, propane, now split into two on the right, propene and hydrogen, and the nature of gases is that they'll just spread out. So it makes sense that if you're going from one molecule to two, that it is going to take up twice as much space, because those individual gas molecules will just spread out. If you look at mass, you do still have the same number of atoms and you would have the same mass on each side, but volume is just how much space does it take up. It takes up more space when you split one molecule into two molecules. Question 9, little one there about corrosion. What is meant by corrosion? If you look at the mark scheme, it accepts the reaction of a metal with oxygen or the oxidation of a metal. They say to just ignore water. You need water for the corrosion of iron, but you don't need water for the corrosion of all metals, so it's not in the definition of corrosion. But yeah, oxidation of a metal. And then this one down here is similar to the other ones we've seen. You're starting off with sodium azide. They tell you that sodium azide is NaN3, and they give you the mass of sodium azide and they ask you for the volume of nitrogen. So I'm putting sodium azide and nitrogen into my table. I've got 110 grams of sodium azide. They tell me the formula mass is 65. Mass divided by mR is moles. And then the ratio between sodium azide and nitrogen is 2:3. So I divide this number by 2, multiply it by 3, and work out the number of moles of nitrogen that I've got. Again, if I were to continue filling in this table, I'd be getting mass of nitrogen. I'm asked for volume. So I take my moles and I multiply by 24 to work out the volume of nitrogen produced, and I get 60.923 decimeters cubed. But they ask me for centimeters cubed. Okay, when you times by 24, you're always getting your answer in decimeters cubed. You must then convert to centimeters cubed, and you do that by timesing by 1000, and you get 60,923. The last question up here, just a little multiple choice. What volume is produced by the complete reaction of 750 of sulfur dioxide? So you're starting off with sulfur dioxide, you're making sulfur trioxide. You'll see that the ratio between the two of them is 1:1. Therefore, 750 decimeters cubed produces 750 decimeters cubed. Okay, so your answer there is B. As I said, that's all of the questions, and if you can do all of them and do them comfortably, you should be well placed for this topic in the exam.